All right. Hi, good afternoon. My name's Tom Fetherston. I'm going to give a talk on how to read code. And it's kind of more general than that because as programmers, enthusiasts, there's an awful lot of stuff out there. We got to learn an awful lot of stuff. So this is kind of like reading code, reading. And I'm an enthusiast for Python. I've got a CS degree I got a few years ago while I was playing around in between jobs, and it's the quickest way to get out of college with all those accumulated credits. But no one's been foolish enough to actually hire me to code yet, but we'll see. Okay, so this is about reading code. And the genesis of this talk was, I'm in the library and they're, getting rid of books and whatnot. And I come across a book on content area reading, which is, education book for teachers, how to teach people how to read. And I thought, I wonder if there's any cross between this and actually reading code. And as it turns out, there are a lot of things that this points out that are applicable. So that was kind of the genesis of this talk. So let's start out. Okay, so originally this was going to be a talk where I was going to do like a code walkthrough and like just show you, okay, this is a good tool to do this, this is a good tool to do that. Turned out there's an awful lot of stuff here. I mean, I do have a little project I can talk about. It might have made it into the notes, but we may or may not get to that. I just found there were too many techniques. So I'm not going to be able to do this in 40 minutes, give you a very detailed view because there's just so many tools you can have in your tool set. So if I can use an analogy, I've installed medical equipment, and worked on medical suites and that sort of thing. And when you go on the installation, you've got your tools there, you've got other people with their tools, you're working on something, you put the tool down, somebody else takes it, you don't remember where you put it, you don't get your tools back at the end. So, this is just the way it went. And then I ended up working with this guy who had his own system for tools. What he would do, he wouldn't worry about my tools, your tools. He would keep his tools. He brought in 3 bags, and he had these bags labeled, well, at least conceptually, twisters. So this were tools like screwdrivers, you turn something. He had cutters for saws, scissors, that sort of thing. And he had a bag for smashers, hammers, and that sort of thing. And so he would put these 3 bags out, and, whenever you used the tool, you would put it back in that general tool bag. So what I'm going to do here basically is bring my bags of tools, pick out a few, and then it'll be up to you to take some of these tools home and, put them back onto the old pegboards and whatnot in your own, mental workshop as you read code and whatnot. So here we go. Like I said, it's a collection of hints at this point. Okay, there'd be 2 worlds that we'll be getting our techniques from. There's a world that I mentioned that this book covered, which was, teaching content area reading. Now, if you're not familiar with that term, what they mean by that is, there's a way to read, just general literature. There's a way to read in, history subjects. There's a way to read into physics and science and biology. And what they wanted to do was to teach people how to do that, how to adapt to the area of content that they're reading, and how to develop techniques of reading for their students. So I'm going to throw out some things from that. Then there's the world more specifically of Python and more generally just computer programming. And there are some things that specifically applied to that area and come from that world. So we'll go over things like that. Okay, so first thing, just going to talk about some things that apply to both worlds. We have a problem with code, and if you were in the talk earlier, one of the earlier talks, he was talking porting 500,000 lines of code and that sort of thing. So it's kind of like, how do we deal with things that are that massive I mean, just the included batteries, included libraries and whatnot. You know, a lot of people don't use that because they, haven't delved into it and they don't know all the functions that are there, because there's a massive amount of code just there. So how do we deal with things like that in general? Well, there's a technique, something called chunking, which means instead of dealing with, all the lines individually, you've got to come up with ways to, like say, well, these 10 lines, they form a higher unit that I, have conceptually in my head. And so I don't have to remember those lines individually, word for word, because that's not the way the human mind works. You just have to, when you get familiar with code, depending on what level you're going for, you've got to deal with things at a higher level. And one of the big memory techniques is chunking, because, there's that old rule. You can only hold 7 things in memory at one time as you're going to memorize it, 7 plus or minus 2. And so the way you deal with things that are more massive than 7 is create units, subunits, and then you just hold the units in. So you're still just working with a few number of things at a time. So that's chunking. Now, another thing you've got to look at when you're dealing with learning or reading the code is, what's your purpose? There's purpose for general reading, for, what are your purposes there be? Well, if it's a science fiction paperback, you don't have to do much more than read it because you're reading it for entertainment. But if you're reading it for learning, there's some things you can do to, facilitate the transfer up into your head if it's something that you're, going to need further on down the line, like when you got somebody on the operating table or whatnot. What was that thing from Not a Good Time? Not a Good Time. So we got similar purposes that we've, you might have going into doing some reading of code. You might be going into, as you're starting out to, what's good style in this language? So you might be reading for that. You might want to learn the different ways to structure an application. So you might be going in to read for, okay, what's the structure of an application and how's that laid out? Specifically in Python in this case. You might want to create a similar program. You might want to add a feature, just dive in real quick, shuffle around. Oh, here's where I can put this, and here's something that's similar. I'll just pull that code out, look at it, structure my code like that. So that might be a purpose. Or you might want to, contribute to a project. It's something that really excites you or something you're interested in, and you might, you want to get that project at a deep enough level where you could become one of the main developers for that. So that's another level of purpose you might be reading for. So we've got those two things that kind of apply to both. I mean, in just reading to learn, you have a purpose. Reading code, you'd have a purpose. Okay, this is going to show up there. All right, techniques from the world of teaching. This slide's way too long, apparently. This is a quote from Johann Wolfgang Goethe, the man who wrote Faust. Those who make the assumption that literacy carries with it the ability to read do not know what time and trouble it costs to learn to read. I've been working at it for 80 years, and I can't say yet that I am completely successful. So it's kind of the approach you want to take of this. There's always more to learn we want to get some facility with this. So it may be time to go beyond our assumptions that we already know how to do it. All right. Okay, these are some techniques I go over from the world of teaching reading or content area reading. Targeting to learn, writing to learn, vocabulary and concepts, prior knowledge and interests, study strategies, study guides. And I'll try to reinterpret them in the world of reading Python code. Okay, talking to learn. Now this is kind of the hardest to adapt because usually when you're reading code, there's only you. So there are ways that we can adapt this that I'll talk about, but you might want to look at, can you get someone else involved with, going over this code. I mean, if you're just starting out and you want to learn things, it might be a good idea to, get with somebody and like go over one of the modules in the standard library, and just go at it together in pairs. Or you might want to do it online. Or if you're still doing it by yourself, you have the option at times to like just go out and ask a question on one of the Q&A sites. And something that might guide you and get you over some humps that you might incur. Or, you could start your own hashtag on Twitter, and see if anybody latches onto that, or get an IRC channel. So there are ways to like talk that, get you out of just having yourself. But if you got yourself, I mean, this is the age of technology and whatnot. And, there are plenty of apps for like recording your voice, so you can make like a lightweight trail of things. There are apps where you can like have a mind map that takes picture notes and lets you enter text, and also lets you record your voice and whatnot. So there are things available today through technology that can make it so you can talk and capture that. That's one of the things I find, I'm studying something, and having great insights. I really got this little piece of code, and I, had a thought of like, I could do something over here with that, and 5 minutes later, if I haven't captured it, it's gone. We got technology today. Now there's some techniques that they go over, something to like guide you when you're talking. And you'll see these repeated in some of the other approaches. There's what they call know, want, learn, or KLM. You want to like say, well, what do I know about this already before you start? What do I want to know? And then after you've wrestled with the material a while, what did I learn? It's a way to structure your approach. Another thing is what they call directed reading. Now, this is where it's harder to do when it's yourself again. But the idea is you want to like see what you're going after inside of the code, and what thinking activities reading something could call forth for you. All right, so now another level is writing to learn. So in writing to learn, and it's a valid way to learn something is write about it. So break this down to like 3 types of writing to learn. There's exploratory writing. That's where you're just starting out. You're just starting to wrestle with it. You make some observations. So it's kind of messy, tentative, unfinished. It's just like when you're first noodling around with things. Now, another level, it was just essays in the book. But, we have the option today of like creating blogs. There are a lot of people like go into something and they like see where they get with it, and they want to like share that out there in the world. So they put it in their blog. And whether you do that or not, you can come from that. It's like, okay, if I was writing a blog, what would I say about this bit of code that I read here? How would I guide someone through it? There's something they call discourse forms, a lot of which aren't applicable. But basically what a discourse form is, you're just playing with one form of writing, and you're like varying your viewpoint of like what it would be to come at this from being this person. Like for history, it's like, you imagine yourself as a pioneer and writing in your little diary and, writing Little House on the Prairie and whatnot. I mean, you have the option of like doing things like that where, you can take the viewpoint, okay, what would a newbie, how would he come at this? And, that could be a discourse form. You could, well, if you've got enough good enough model, you could pretend to be some other programmer that you know who's like really opinionated and has this distinct way of looking at things. You just pretend to be Gary Burkhardt if you know him, and just like, okay, what would Gary say with something like this? Just another way to look at things. And and just coming at it as a blog's kind of a discourse form in itself, because that's just a form of presenting information. And like I said, they talk about like unsent letters. There can be unsent blogs. Doesn't really mean that you're going to like publish this as a blog, but it's just a way to structure your approach to this. Excuse me. All right. Another thing, that's had a lot of value down through the ages is journal writing. There are, scientists keep journals. Diaries are a form of journals. There are lots of journals, and they've had a lot of value in the past, and they can bring some value to code reading. And, as geekier people, a Python conference, come on. We tend to approach things pretty intellectually and whatnot, and, but the truth is, we're complete human beings. And the idea of like response journal is you're not capturing just the information that you're getting, but you're trying to capture a bit of, how do I feel about this? What are the emotions that I get? What's going on in the whole experience of like learning this? What's that eliciting that in me? And trying to capture that. I have this theory about like recall. When you're trying to recall things, if you've gone and pared things down to like the bare minimum and you're trying to work just from the bare minimum, you're actually cutting out a lot of the clues that will let you recall things and work with code. So, you might want to look at, okay, well, how are things, how is this talking to me? Double entry is another form of that. You're kind of like saying, well, I had this reaction to this and this, the left-hand column, and then what you learned, over in the right-hand column. And, it might be something like, oh, this is a really cool way to do this, or I saw something similar, in the past over here. This kind of reminds me of that. Little notes like that. And then there's just a learning log. You want to keep track, short little notes of like, oh, I learned this, time and date stamp it. I learned this. Just little reminders of what you actually covered. Okay. Another thing when you're reading, you got to have vocabulary and you got to have the concepts. That's why we're reading the code. And you shouldn't consider this separate. It's like you don't want to be like, okay, I'll read this and then I'll they just introduced generators or something here. I don't really know those yet. Okay, I'll go and look that up. Like that's a separate activity. It's really part of the whole reading of it. Yes, you're still going off and looking about generators, but you're also putting it back into the code that you're reading. So you're get the sense of what you just read meant, so you can build up the concepts, increase your knowledge on the areas that you may have not seen before or you're weak on. Yeah, I think I better hit this. Okay, if I can get it open. Why don't I get my assistant? That's what he's for. The water opener, water boy. So, direct experience is the best teacher, but we have a thing here. It's code. Where's our direct experience with that? Maybe in pair programming where you're sitting down with someone, you're getting to watch how they're doing things, and you're getting to see how you do things. Thanks. But mostly it's canned. It's canned in the code. So, we got to do the next best thing. We've got to, kind of have ways to mock it up that it's direct. You can pretend I just wrote this, and you could go, look at it from that way. Well, okay, just trying to make it more personal. There's more personal involvement with what you're reading rather than just, this is body of code. I got to get through X number of pages, and once I'm done, I'll have it in my head. No, I mean, in looking at memory these days, they've discovered that, when you go hit a memory in the past, it's not like you're going back to the past and pulling out some tape that's got the whole incident recorded on it and putting it in and playing it. It's really reconstruction. I mean, you're going into what you call the past, and you know some parts of the incident, and you really kind of like make up the circumstances that would like match that. And people have a lot of trouble with this because they really think that, oh yeah, I really got the true memory, but that is not the way memory works. And in code, it's like I said, it would be ridiculous to try and like know a body of code line by line, word for word. You've got to like suss out the patterns in the code and, use those and your experience with code to like kind of recall generally what it's doing. So it's more like in truth, it's more like a feeling that you know what the code's doing, and you know how to get around in it that you're going for, rather than like knowing the code dead on line after line. Okay, so vocabulary comes in three parts. I mean, there's just everyday words. You don't have to worry about that. There are special words. With the special vocabulary, that's like everyday words, but they're being used a little bit differently. And then there's technical vocabulary, and that would be something specific, like generators. I mean, that's not a concept that you see in that many other languages, or at least not by that name. So those are forms of vocabularies. Now, concepts are the things that we're trying to capture with words. I mean, when you have like a concept and its definition, there could be 1,000 words like describing that concept. And the idea here is, again, it's that chunking concept. You want that word that's, naming that concept to like stand for all those words that, explain that concept, so you can like hold it in your head with the smaller word in its place. So, and the thing about concepts is, you learn them, you've got to like look at the relationships in between them. So, there are always concepts that are, at a much higher level that may have subparts. And, as you're learning things, you want to be cognizant of that relationship with the things that you're learning. So to do that, I mean, some tools to like keep that in your forefront. You might like take your concepts, group them into hierarchies, graph them out with little sticks, You might want to like look at the concepts and like see, how, on a scale 1 to 5, do I know this? What's my understanding of this at this time? Another activity you can do, you can like take the concepts and like sort them out into different categories, and then, give them labels. Okay, prior knowledge and interest. This is kind of the glue between learning. I mean, you're always building on something you already know, and it's the only way to learn. And to be more successful at that, you want to build up your interest, your expectations, so you can read with purpose and anticipation. Programmers were, we got this bad habit of like, okay, I just want to code, and so we jump into it. And, our teachers have been railing at us for years. No, that's not really the way to do it in real life. You'll learn that eventually. You got to have some thought beforehand. When you're reading code, you got to put some thought into it to begin with anyway. So a way to do this is to like build up your interest, build up your expectations, define, say what your purpose in reading this is. And like, it's like you can be excited to like learn this. It's like, oh, I've been meaning to learn about generators. There are quite a few in this example here. This is a good time for me to like figure that out. So you want to rouse your curiosity about what the code's doing. You want to make predictions about how it's doing that. Because you already got enough knowledge to like, well, there'll probably be these methods in there. They might use state machines or something, different approaches that, I'll probably see. And you want to like make those predictions ahead of time so you can like read and then see if it's in there. And you want to ask questions ahead of time. You see, I'm reading to get answers to this. Okay. Some strategies to study. You make pictures. Now, Python doesn't have a lot of pictures in it. I mean, there are other languages that, there is UML, a lot of that stuff in Java and whatnot. We don't use that sort of stuff in Python because we're blessed with a language that doesn't require it. But there's nothing wrong with making pictures to understand what's really going on. You can write summaries. This block does this. There's a style now to like not put a lot of comments in code, but like if you're reading it, you're kind of making up your own comments. You want to follow the code structure. I mean, really, the code structure is, at a high level. I mean, that's a high enough level that you can like get some feel for that. This is, we're going to have to use sequence. We're going to have to do some conditionals here. We're going to have to loop over something here. And those are higher level concepts that can stand in for a lot of codes and do a little chunking for you. You want to make notes as you go along. And you might want to use study systems. Now, this was my only study systems is something, I can remember in English class they tried to like teach us this SQ3R and whatnot. And, it was a good study strategy, but after a while you didn't really like follow it because it's like too many steps and you just wanted to get the paper done and get out of class. But now that we're doing this from ourselves, we can bring these back in. And once again, with technology, it's not as heavy as it used to be. We can capture things in a way that's a lot lighter weight. I'll speak to that when I get to like technologies we can use. Study guides. Now, study guides are there to like help you get through code, to like inform you in your reading of the code. Now, there are, you won't necessarily, or you won't find, a study guide to every piece of code you want to study, but there are study guides out there. And, if you're reading Python to learn Python or to learn to be more Pythonic, there's module of the week. It's the blog, and it actually turned into a book where somebody goes over the standard modules, and talks about them. And you can like use that as a study guide when you go in and, study that same module. Books will often talk about, a particular, a code in a way that's much like a study guide. So that's available to you. And if there isn't any, you can make your own. Again, with the, you could be using that idea, well, like, okay, what if I was writing a blog and, I was doing my own module of the week. So there are various types of study guides that you can use. You can put up a guide that's a guide to patterns. Now, I'm going to talk a bit about patterns on a bunch of levels in a bit. But you probably run into the concept of patterns, and even if you hadn't, it's not that difficult an idea. It's like there are problems that there are common approaches to. Why reinvent the wheel? Follow this pattern the way other people follow them, and codify it, give it a name, and then you've got that in your toolkit. So you could be reading the code and looking for patterns. This is often a good thing to do because, again, that's one of those chunking concepts. It's like if I know that, this half a page is from this pattern, it's defining classes to do this sort of thing. It's a factory pattern or it's a delegator pattern. Just knowing that, I've like summarized all that in a form like if like I lost it, the hard drive crash, I could like use that to recreate it. And that's kind of what we're going for. That's the understanding of the level of code that we're going for. There's a concept guide. I mean, what concepts are being introduced here? There's something that is called selective reading guide. That would be, that's a little bit more lightweight, and that's more in like if you were like guiding someone else. And you can pretend that, okay, I'm going to be teaching this at class tomorrow. You can take that as a way to inform your interacting with it. And a selective reading guide is just like, okay, in the block of code from line yada da to yada da, find the variables. Why did they name this call that way? Things that would like guide the thinking of someone who came after you into like being able to make their way through the code. Okay, so let's go on to just programming and leave the world of content area. So as I was saying, patterns, they're really just another word for chunking in a way, because they're really a very powerful way to deal with your code, because you've got to compress it in order to be able to hold it in your head, and deal with it at some level. There's a whole body of work called design patterns. Now, Brendan Rhodes did a talk on design patterns in Python last year. I'm going to have that in my notes on that, but it's up on YouTube. And what he found when he was looking at, just the basic, there's one standard book called Gang, by the Gang of Four, they call them, which kind of introduced the idea of design patterns in the first place. And what Brandon found is that Python actually has a number of the patterns in it built in, that they don't really have to be in our toolkit, because Guido and the people who made Python for us, like, put those patterns into the language, and they're just there available to us. But there are some that, actually can, and do need to be coded up when you use them. And so it's good to be able to deal with design patterns at that level. But I just recently came across a book. It's on creativity, called Inside the Box Thinking. And Inside the Box Thinking is like going against some of the ideas that you may have already had about creativity. I mean, brainstorming and coming up with ideas and not, criticizing until it's the time to weed out. These people found that, that's really not where you get the most creative ideas. Where you get the most creative ideas is when you take the world as closed and you only use what you have around you available already. And the reason why I bring this up into relation to patterns is they actually have like just 4 patterns that they use to foster creativity. And it actually goes back to work of this Russian engineer back in World War II. You may have heard of it. There's I think it's called TRIZ methodology, where he found in like analyzing patterns that when patent inventions came up, they followed basic formats. And there were basic patterns to creativity. And he had 30, 40, 50, 60 of these patterns and whatnot. And these people have taken that work and like reduced them down to 4. And so again, I'm looking at this. It's actually, it looks like it's going to have a lot of applicability to the world of programming. But again, it's like, okay, when we can get all the different design patterns, and there are hundreds or thousands of them at this point, and just be able to categorize them into 4 different types of patterns. And they're simple. It's like, okay, look at subtracting something out of what you had. It's very applicable to code when you're thinking about it. It's like, okay, these are the parts of my code. what if I took out that object? How would that change my code? How would I have to adapt my code to, have it work again? And does it make any new possibilities available to me? Having that module. I mean, maybe I'm just like stuck and fixated on, oh yeah, this is just the way it has to be. Just the idea of like taking out that little code can like really foster your creativity, and it can also be used to, in this case, to understand things, because you can, I mean, unless you're dealing with pure genius, there's always improvements that can be made to code. And you want to see that because you want to be able to do that for yourself. So, like I said, very interesting book. I think it's going to have applicability to software writing at a high level. So that's one way to, categorize patterns. Then there's, different classifications you can have of patterns. I don't want to install important updates. Thank you very much, Windows. There's use case patterns. These have to do with how your user is going to use your software, dealing with the interface issues, which is the next one. There's logic patterns that encode business logic. So these are different patterns. I mean, there are books. There's resources on the web. A lot of this stuff, unfortunately, seems to come from Java. I mean, they seem to deal with that the most. So if you do get one of these books, you've got to do some translating. But there's some gems there, so it's worth some study. Okay, so another way to chunk code is, just something to be cognizant of. There's what's called Pythonic, or Python idioms. That are like ways that we use the language that are different from other languages. But, if you try to use the way you know how to do things from other languages, you won't be doing it Pythonically. And so, if you've got these, idioms in your head, or if you're on the lookout for them and you're always adding them to your toolbox, and you can do a bunch of that by studying the standard library, because a lot of that code is Pythonic. I mean, then you can, you're again chunking. It's like always using, tuple unpacking to set variables here, or to avoid having to swap variable. There are these patterns that we have that are just like part of the language and part of the convention too. I mean, they're not necessarily built into the language. It's just the ways that people who do Python do it because they feel it's the most beautiful way and the most succinct way to do it. Okay, these didn't get filled out so much. All right, so naming guidelines. Looking at namings is a big part of being able to deal with code. And there are a lot of different, patterns in naming. Brandon had, talked about this in one of his talks. It should be in the notes. There are a number of, there are videos on the resources for this. There are blogs on the web talking about naming conventions. If you got a function, you more than likely you want a verb in that function's name. Variable, it's going to be some noun for it. And, we're dealing with combo names and whatnot. Another pattern is like name and then verb, So there are these naming conventions and you need to be like on the lookout for them. And, a good way to interact with your code is like, is this the way I would have named this? Or is there a more, a way that communicates more? In Brandon's talk, he was talking about, refactoring this code. And, often that just meant looking through it, choosing different variable names that communicated more accurately what he was doing than the words that he, the names he used in the beginning. And just by doing that, it made the code more understandable. It was true to what was actually being done. And, he said, if there's one thing that he could do, if he could go back to, and talk to himself, 10 years ago, he'd say, when you got your code written and it's working, you're halfway done. So they're just refactoring for understanding. And you can use this as an exercise, something to motivate you as you're reading. Partitioning of functionality. We do that in several ways in Python. We've got modules which form their own namespaces, and that's a good way to partition out the functionality of what the program's doing. So when you're reading, you want to see, well, how did they set this up? There's classes, which is more. It's actually used more in other languages than Python. Python actually, with the ideas of modules and namespaces and whatnot, can do a lot of things without classes, so we don't really necessarily have to go to classes. But classes are another way of classes have their own built-in namespaces and whatnot, and sometimes it's more natural to deal with things in terms of classes because you're modeling something that's occurring in the real world, and there are analogs to help guide your thinking. But when I was working on my degree, it's like objects were the thing that we're going to stay programming and make it, the new way to do things. And found out not so much. All right, so let's see where I am. Thank you. Okay, so when you're dealing with classes and functions, you've got attributes and methods. But a higher level to think of that is, okay, what responsibilities am I dividing up between these classes? The responsibilities in terms of retaining data, persistence. There's responsibilities in terms of providing an interface. There's responsibilities in terms of the internal workings that drive that interface. And, just dealing with it in terms of responsibilities instead of, the actual nitty gritty. Okay, this is a method. This is an unbound function. Gives you, a higher level to interact with things. All right, so technology. It is the 21st century. We do have a lot more technology than we used to. We don't have to deal with it with paper and pencil or even just our screens anymore. There are a lot of tools that we can bring to the forefront. So let's see if I have anything. There's technology to help capture things. There's recording apps. There's screencasts. Now, I recently saw a demo by a Microsoft employee. He'd seen something that came out of PyCon where someone was using voice activation to get his way through Emacs. And he thought, Vim would be great for this. I'd like to have that for that. So he coded up in F# his own solution to that. He used .NET and whatnot. F# isn't my language. But what he did was he then navigated through the code. He demonstrated it, but then he navigated through the code and he talked about the code, as a screen capture, as a video cast. And I was like going, well, heck, you're going through code. You're trying to figure it out. Why not capture it as you go through it? You can talk about it right there. You got something to go back to. One way to review things is to get as close as you can to what all was occurring in that experience the first time. It's a perfect way to capture things. Memory aids. There's one program I like to use. It's called Anki. I don't know if anyone's familiar with it. It's a Python app. And it's a flashcard program. There are lots of things we got to get up in our head. And, at a certain level, this is a good aid for you. And it's a really cool program. It's got so much potential because it uses Python, uses a database, and it uses WebKit. So, you can do all sorts of colors and CSS sheets and JavaScript and do really fancy things that, you wouldn't imagine you could do to make a really, impactful presentation. Not saying there are much examples out there yet, but it's got a lot of potential. And it's Python, so it's something like I want to be reading and checking out with. your editor. Getting familiar with your editor, because, like I said, you're dealing with a lot of loads of code. I mean, really, your editor's, it's the one that can know all those lines of code, letter by letter, word by word. Let it remember it. Your job is to be able to bounce around inside of that code using your editor, using the ways you search things, the way you find things, the ways you grep for things to get around and, pull things out of the code that, you need to pay attention to. Get to a routine, run C tags on it, and go through the tags until you can pull out the definition of a function as you encounter it. There are lots of things in your editor that are built in. One of the most useful ones that I could recommend is there's completion. We all use completion. We don't like to type out these little big long identifier names and whatnot, and they can get pretty darn long. But really, the built-in completion is a little dumb because you're typing out the first part of a word. Well, there's something that's sometimes called an acronym. Yeah, this is going to look good on the video. Let's postpone again. Where was I? Yeah, I mean, there's something that, yeah. Okay, let me finish this up then. So I have a little bit of time for questions. There's something that's called acronym completion, where you type the first letter of each word in your identifier, because identifiers are usually combo words, and then you complete on that. It's a much better way to, complete, because you're keeping in your head something that actually, relates to you remembering that function name, as opposed to, oh yeah, it's one of those things that starts with combine, and then just picking it out of a list. All right. Outlining is another tool. I mean, your editor will probably do this code folding, which is a way to concentrate things so you can pick out the points. There are other editors or other plugins for your editors that will go through and give you a two-pane editor. Let's see if I've got that up. So here I've got on the left, on the right, I've got the Python code. On the right, strictly computed and not actually a file, is there's the salient points that let me navigate inside of this code. This is a plugin for Vim called Voom, V-O-O-M. Very interesting, very good way to deal with code. Thank you. I don't want a new tab. Did I just kill my editor or what? No, there it is. All right, graphic tools. We don't use that so much, but there are tools available to make graphs, simple graphs. There are tools to take ASCII drawn graphs and turn it into nice, pretty ones. And here we get to Catherine's talk later. We're just talking about dealing with the text as written, our code as written. We really want some tools to deal with it when it's running, and Ipython is a perfect tool to do that. Now with the new notebook features, you can do those explorations and save them so that they're available to you. And another way to deal with running code is to write your own code. All right, and this is what I said the talk was going to be. It was going to be dealing with this application called Plover, but I don't think we really got time on that. There was actually a presentation at PyCon that's available. Just one thing to say about it: it's like the future of typing. If you've seen stenotype machines, no matter how much you improve your typing, and you may or may not type at a really horrendous rate. I know some people who do. I don't. You'll never match what a stenographer can do, and this makes stenography available. And oddly enough, the person who writes with this uses Vim and uses it to control Vim and to enter her code right into Vim or whatever she's making. And she's actually a captioner for blind people. Not blind people, deaf people. Wouldn't be so good for blind people. Captioner for deaf people. That's what she does for a job. And this is a free and open software written in Python that does this. And so it's a really interesting code base and something that I want to do for some of the things I do. Okay, we probably only got a minute or two for questions, if that. Any questions?
What's your book
That
you were holding up earlier?
You want? Hopefully, it'll get in the slides when I put my slides up on Twitter. Yes, I was going to do that and have these in the slides, and when I actually get them up there on my GitHub account, and I also signed up for Showbar, so they should be able to get you to the notes too at some point.
You mentioned the Russian engineer with the four thing. Was a tryst like the four letters or an acronym of that?
It's TRIZ. I think it's what it's known by. You can look it up on Wikipedia. It was interesting work. I mean, it's like a cheese knife. Okay, you cut cheese with a knife. What can you take away from the knife to make a better knife? Well, take away the part that's making up the blade. And there's several approaches to that. There's the wire. There's the knives that have the holes in it. He just found these patterns that just kept on recurring inside of patterns, and he advanced engineering in a sense, and this is another step along that way. So that's why I would recommend that book. Anything else? Oh, Catherine.
So there are book clubs for mysteries and novels, and is there a book club for code?
Well, it's interesting you act. I just ran across something. I think it's called like Programmer's Workshop, where this teacher was telling his students that he was like opening up a site where people could like track, like athletic sites where you track, how many miles you've run or how many that. It's like for exercises and learning coding, like make a promise on a module you're going to study, make a promise on practicing some typing, learning your editor a little bit better. You make goals and you can talk about it, and it's like got social functions to it. Not sure how, what a bigger presence it has now, but there are those things, and there are code dojos and things like that I'd like to see more of that happening. All right, thanks. Okay. No.
D3.js.
So it's stuff for JavaScript?
It's a D3 library. I don't know if you've seen a lot of the visualizations they do, like in the New York Times or whatever. Mike Bostic.
So like animated
code visualizations. He's got.
that would be cool. There's a
If you can get online, I'll point to the site. But go to d3js.org, and then there's a link to some of his stuff. He's got like browsable, interactive examples of browsing. Major pieces of code. So it's quite interesting.
That'd be cool. Very cool. And I'm very visual, so
So you'll get some of it is digraphs, some of it is matrices in relation. Sometimes it's like heat maps for viewing code. So it's
that would be a very good resource. I'll definitely look it up. Thanks. Hey, Ken. Okay.
if you get online sometime, I see you or whatever, or just go to d3js.org, and then there's a link to examples.
Well, it's going to be on. There's also a service here that has Showbar, collecting links and presentations.
How do you put this thing on? This is weird. Get it?
against the whole. It's mostly C++. It's about the only book there is on code reading. So it wasn't really that applicable. But it did introduce the idea that
All right. You're supposed to actually put that behind you, aren't you?
oh, you're flipped. There you are, Damien.
This was your PyCamp this week.
Yeah, so you're
Say the most Pythonic thing is the standard libraries.
well, there's a lot of Pythonic stuff in the standard libraries. In fact, in the notes, there should be put some other people's recommendations, specific libraries to look at. And there's actually a book, too, it's only available as an ebook called Python Idioms.
No water.
There's over the different ways there are writing things in Python. Thanks, Damien.
看我不能吃了，我男的7点钟吃饭吗？你中午几点吃的饭？那你到7点钟吃也不好。
This one yours?
Yeah.
Whoa! Well, that's not supposed to be like that.
我对看农业不太。
Sorry about that. I thought you were.
Why am I left?
Where's my mouse? Why can't I find my mouse pointer? Hello, mouse pointer. It's way over there. Oh, that's the problem. This will screw you up. Damn, I can't find it. Over here. Come on. Alright, this is just really weird.
So, Chad, why don't you dress like yourself?
Dress like I'm self-employed?
Oh, okay, good. Thank God. I was getting really.
So you're self-employed now.
Yeah, it's
Being busy?
it's a learning curve. Right now, we landed basically send out throw proposals, and everyone's like, "Yep, we're in." And our original client, we decided to give the system, all right, let's do this.
What the hell just happened? Oh.
I don't do project building, that's realistic. So I try and still take. Yeah, I just say, how about I budget X hours a week? And I say, the deal is around so far, that's but I also love like 10, 15 hours a week.
Like the original two were now called
Look at that. Plug in the compass from beyond the grave.
Oh, is that the. That's not the right slide.
There is the microphone over this.
Mike, you're wearing it, right?
Oh, are you wearing it?
Yeah,
Oh, cool. Yeah, go ahead.
I got that, I think. I think we're good there.
You got your mic, you're set.
I'm set with that, and if only I can get the computer to behave properly, we'll be in good shape. But you know how it is, these things never want to behave.
Especially when you need him to. You need to get AV up here?
No, I just need to figure out how to actually use this thing with two monitors on it. Yeah, I'll just do this. All displays. Okay. Slideshow. Except that's not the first slide. How do I get back to the first slide? Come on. There we go. Alright, I'm good. Alright, hey, alright, we're good.
Some stuff. Thanks.
Can I say some stuff? I'm saying some stuff. Is that good? Alright.
One more minute.
Take it to the hoop, Mike.
All right. Thank